Hi everyone, welcome to part 2 of this walkthrough of the foundation paper 3 from November 2024. We're on question 11. As you can see here, we've got to use this graph to change between miles and kilometres. The question says change 10 miles into kilometres. Now we don't have any equations here to use, so it wants us to use the graph. We'll go up to 10 miles on this side, come over to the line, and then read down what this says. And this is 2 points in here, and each 2 points is equivalent to 1 between 15 and 20. So 2 points down here is 16, so it's 16 kilometres. Okay, part B. Rob drives 17 miles from Billington to Scarborough. He then drives 50 kilometres from Scarborough to Staithes. What is the total distance Rob drives? Okay, so we've obviously got two different units of measurement here, and we want to be able to convert them to the same measurement. Now, because the answer says give your answer in miles, I think it'd be better here to try and convert the kilometres into miles. Now, you can use this sheet here to try and figure out a rough figure, but the easiest way to do it is to remember that 1 mile is equal to 1.6 kilometres. Now, if we know that, we know that 50 kilometres is equal to something miles. So, all we need to do is divide 50 divided by 1.6, and then we find out what the equivalent miles are. So, the equivalent miles are 31.25 miles. Okay, and now we have the kilometres in miles. We just need to add that to here, to 17. So we do plus 17, and that is 48.25. So we'll put in here 48.25 miles. There we go. Question 12. A shop sells apples and oranges. There are 6 apples in each pack of apples. There are 7 oranges in each bag of oranges. The shop sells X packs of apples and Y bags of oranges. Write an expression in terms of X and Y for the total number of apples and oranges the shop sells. Okay, so this is an algebra question. We're going to be rewriting this just in the form of an expression. So in this case, there's 6 times apples and there's 7 times oranges in each bag, in each separate bag. So X needs to represent the apples. So if one apple is X, then we have 6X. And if one orange is Y, then we have plus 7Y. And that's it, that's all it is. So 6X plus 7Y, because this represents bag 1 and this represents bag 2. There we go. And question 13. The diagram shows a crate and a box. The crate is 3 meters by 1 meters by 1.5 meters. The crate is completely filled with boxes. Each box is 20 centimeters by 10 centimeters by 75 centimeters. Work out the number of boxes in the crate. Okay, so it's a volume question, and there's a few ways we can do this. I think the easiest thing to start with is converting all the measurements to the same unit. So in this case, I think I'll convert everything to centimeters first. Now we know that in 1 meter, there is 100 centimeters. So these figures here, we'll just multiply by 100. So in this case, we'll get 300 centimeters, 100 centimeters, and 150 centimeters. There we go. So now we know the correct units. What we need to do is you need to find how many of these boxes fit in here. Now it says the crate is completely filled. So you're going to have no leftovers. It's not going to be like a decimal number or anything. So if we find out the full volume of this and divide it by the full volume of this, we'll figure out how many of these boxes can fit in here. So in this case, we're doing 300 times 100 times 150, which is 4,500,000. I know it looks like a big number, but don't worry, we got this. we're just going to divide it by whatever the volume of this box is. So we can do this in one way. We divide. If you open a bracket like so, and then you do 20 times 10 times 75 and close the bracket, that's just working out the volume of this inside the brackets and then dividing what we had by this. Click equals, you get 300. So all we did there was we worked out the volume of this, which is 300 times 100 times 150, which equals 4.5 million. You should probably write these down as well in an exam. And then 20 times 10 times 75, which, if we work that out itself, it's 15,000. And then we just do this divided by this, and that equals 300 down there. Okay, question 14. Harry works in a shop. From Monday to Friday, his basic rate of pay is £8 per hour. On Saturday and Sunday, Harry's rate of pay is 1.5 times his basic rate of pay. The table shows the number of hours Harry worked each day last week. Work out Harry's total pay last week. Okay, so the only difference that we have here is this 1.5, because we can work out the Monday to Friday pay quite easily. 1.5 is the same as 1.5, just for when using our calculator. Or you can also put 3/2 if you prefer fractions. And then here we have £8 per hour, and that's between Monday to Friday. So all you do is you can work out, well, for one day, for Monday, it's 6 times 8. And then for the second day, it's also 6 times 8. And this is all these 5 days. So all we're doing is we're doing 6 times 8, which is 48, and timesing it by 5, because there's 5 days there that have that pay. So that equals 240. This is for Monday to Friday. Now we've got to work out the pay for Saturday and Sunday. There's less hours and more pay per hour. So we can work this out by doing the amount of hours worked, which is 4 for Saturday, times the rate of pay, which is 8, times this adjustment on the pay, which is 1.5. And that, if we work it out, equals £48 for Saturday. And if we do the same for Sunday, we do 3 hours worked times the basic rate times the increase of that rate, which is 1.5 times. Now we'll do 3 times 8 times 1.5, which equals 36. So now we've got all the days, we just need to add these 3 up. So we do 240 plus 48 plus 36 equals 324 pounds. And we'll just put that in there. There we go. Okay. For question 15, we're looking at 41 children, which is the totals of this, and the age ranges are here. It says work out the mean age. So we need to find out the amount of years in total. So 8 times 6 is 48, 9 times 7 is 63, and we just do these calculations to find the total number of years. So this equals 406, which is the total years. And then we need to divide the total years by the amount of children. And there are 41 children, so the question is 406 divided by 41. If we get our calculator, the answer to that is 9.9. So the mean age is 9.9. And all we've done there is we totaled up the total number of years in total between all 41 children and divided that by the number of children to find an average for each child. And the average is 9.9 years. Okay. Part B, Rohan is working out the modal age of the children in the Blackrod Football Club. He says the highest frequency is 15, so the modal age is 15. Is Rohan's answer correct? Give a reason for your answer. Well, in this case, modal is the most common age. So Rohan is right with the frequency because the most common occurrence is here, but the age isn't 15, the age is 10. So that's why, because the age for frequency of 15 is 10, not 15. There we go. Okay. Question 16. Write 126 as a product of its prime factors. So if we start with 126, we want to divide it by prime factors to try and figure out what the list of prime factors is. And usually the best way to start is if it ends in an even number, we can divide it by 2. In this case, we can use our calculator to divide that by 2, and we get 63. Okay, so 2 is one of the prime factors. Now we can see that 63 is in our times tables as 9 times 7. So let's divide it by 7 first, because 7 is also a prime factor. And then 63 divided by 7 is 9. Now 9, we want to divide that. We can't divide that by 2, but we can divide it by 3. So if we divide it by 3, we also get 3. As you can see here, these are all prime numbers. So as a product of prime factors, it's 2 times 3 squared times 7, or 2 times 3 times 3 times 7. So that is the answer there. Okay. Find the highest common factor of 126 and 210. So I think the easiest way to do this is to draw a Venn diagram. So if we do this, and if we put 126 here and 210 here, now we already know the prime factors of 126, so let's put them over here for now, individually. And the prime factors of 210 we can also work out, so we can do 210. Well, again, we'll divide it by 2, and we get 105. And then we can see there's a 5 on the end, so it is divisible by 5. So 105 divided by 5 equals 21. And then from our times tables, we can see that 7 times 3 is 21. So we have, for this prime factor, we have 2, 3, 5, and 7. So if we write these over here, 2 times 3 times 5 times 7. And if you ever want to check that these are the prime factors, just put them in your calculator and you can see that it does equal the number there. Now, to draw this Venn diagram, the numbers that occur in both of them, we want to put in the center. In this case, 2 appears in both, 3 appears in both, 7 appears in both, and then 5 is left over here, and 3 is left over here. So that is the Venn diagram. Now, to work out the highest common factor, we need to multiply all the terms that both of these numbers share. In this case, we just multiply these 3 together. So the answer is 2 times 3 times 7, which you put into your calculator, is 42. That's it for part 2. Thanks for watching. Please consider liking and subscribing if you like the video, and I'll see you in part 3.